Welcome to Science Access. In today's class, I'll be talking about Charles' law. I'll actually be doing calculation questions and answer. Right? Remember the law which says that volume is directly proportional to temperature, provided the pressure is constant and the mass is also constant. That's the reason why if you see question, they will say a given mass of a gas. The mass is given, it's actually constant. And even if it's not stated that it's constant, know that the mass is what? Constant. So the pressure is constant and the mass is given or is constant. So it's the same. So in that case, you know that you're talking about Charles' law when the volume is directly proportional to the temperature. Now, this sign of proportionality, you can change it to equal to sign when you introduce the K as a constant, then this sign of proportionality will change to what? Equal to sign. Again, how do you change this sign of proportionality to equal to sign? You introduce a constant K, so you now have V equals to KT, where K is the sign of what? Proportionality. All right. Now, how do we now look for K? K in this case to get K, you now divide both sides by T. Why are you dividing both sides by T? Remember, you want to make K to stay alone. So you divide this place by T and you divide this place by T. So that's why we divided here by T, so that this T will cancel out this T. Now, this K is now alone. In other words, we have made K the subject of formula. So you now have K is equals to V all over T. That's what we have here. K is equals to V all over T. You can also put it as K is equals to what? V all over T. So it's the same thing. Now, note that when we have two volumes and two temperature, or when you have initial temperature, final temperature, as well as the initial volume and final volume, you can now rewrite the equation like this. Remember, V all over T. So you can now write V1 all over T1 is equals to V2 all over T2. So this is the origin of this formula you see in Charles' law. So let's quickly take some examples. Let's take some questions. Now look at this question. A oxygen gas occupies a volume of 800 milliliter at a temperature of 40 degrees Celsius. What will be its volume at 80 degrees Celsius? Now, assuming the pressure is constant. Now, note the first volume or the initial volume is actually this, and this is the initial temperature. And what is the final volume? They are asking you to look for the final volume. Why this is the final temperature. So V1 is equals to 800 milliliter. Now, the volume is given in milliliter. You can decide to leave your answer, your final volume in milliliter, or you can decide to change this milliliter to liter. Now, if you change this milliliter to liter, how do you change 800 milliliter to liter? To change any milliliter to liter, you have to divide by 1000. So that's the reason why if you divide 800 by 1000, you have 0.8 liter. All right. Temperature is 40 degrees Celsius. You can also decide to change it to Kelvin or leave it at that. So I will leave mine there. You have V2, you don't know it. So this is what we are calculating for. Why we have T2, which we have here, which is the final temperature. Remember again, this is the initial volume, this is the final volume, this is the initial temperature, and this is the final temperature. So now let's apply our formula. We now have V1 all over T1 is equals to V2 all over T2. Now, what are we looking for? We are looking for V2. So we have to make V2 the subject of formula. So first, I will cross multiply. Use V2 to multiply T1 and use this to multiply. So if you use this to multiply, you have V2, T1. So this and this, they are now combined. If you use this to multiply, you now have V1 and T2. How do I make V2 stay alone? In order to make V2 stay alone, I will divide both sides by T1 such that this T1 at the bottom will cancel this one and V2 will be alone. So I'm dividing both sides by T1. So V2 T1 all over T1 equals to V1 T2 all over T1. So this will now cancel out this. Note that this T will now cancel out this T. I will now have V2 is equals to V1 T2 all over T1. That is the simple way that I got this formula. Now, once you have gotten the formula, it is so easy to calculate. How do you do that? What is our V1? Our V1 is 0.8 0.8. So we now have 0.8. What is our T2? Our T2 is 80 times 80 all over. What is our T1? Our T1 is 40 all over 40. Now, once you have this, it's easy to calculate. Use this to multiply this, and you have 64 all over 40. Divide, you have 1.6 liter as your answer. Now, note this. Remember, volume is directly proportional to temperature. That means if volume is increasing, temperature is increasing. So when the temperature increased from 40 to 80 degrees Celsius, the volume actually increased from 0.8 to 1.6 liter. So I hope you understand the logic. Let's take a look at another question. Now let's take a look at question number 2. At constant pressure, a gas occupies a volume of 20 milliliter at a temperature of 120 degrees Celsius. Now, this is our volume 1, and this is our initial temperature, right? That is our initial volume, these are initial temperature. What is the volume? You are asked to calculate the volume when the temperature is reduced by half, when you reduce the temperature by half. So in this case, volume 1 or initial volume is 20 milliliter, which is the same thing as 0.02 liter. How do I get 0.02 liter? To convert milliliter to liter, you divide by 1000. You divide by 1000. So if I divide this by 1000, I'll have this. Okay. Now, the next thing you should talk about, what is our T1, the initial temperature? It's given here 120. What is our final volume? That's what we are looking for. And what is our final temperature? The temperature is reduced by half. So you divide the initial one by 2, and you have 60. That's simple. So you apply the same logic I did. V1 all over T1 is equal to V2 all over T2. In this case, I cross multiply to make V2 our subject of formula. So now I have V2 T1. Remember, if you used to multiply this, you have V2 T1. If you use to multiply this, you have V equal to V1 T2. I cannot divide. I want to make T V2 the subject of formula. So in order to, how do I remove this T1 from this place? I'll divide both sides by T1. So we now have this all over T1 and this all over T1. So this will cancel out this. Note that this will cancel out this. So that we now have V2 is equal to V1 T2 all over T1. You simply apply the figures that you already have. What is our V1? 0.02 liter. So we have it here. What is our T2? 60. You have it here. What is our T1? T1 is actually 120 degrees Celsius. You have it here. Now note this. If it's an objective question and your final options are in milliliter, don't bother to convert. Just solve your question in milliliter. Or if it's in liter, your final answer is in liter, then solve your answer. But if it's a theory question, you can decide to leave your answer in this if you are not asked to convert, or you can decide to convert. Either way, you are correct, because 20 milliliter is the same thing as 0.02 liters. Okay, so take note, once you have done this, you just use it to multiply this, you have 1.2, then divide 120, and if you divide, you have your 0.01 liter as an answer. Or if you want to leave it in milliliter, just use 1000 to multiply this answer, you have this as your answer. So the last question for today, we have question 3. Helium gas occupies 2/3 of a container at 60 degrees. At constant pressure, what portion of the container will the gas occupy if the temperature is reduced by 1/3? Now, V1 is 2/3 of the container, 2/3 of the container. T1 is 60 degrees. This is the first volume V1, and this is the first temperature. So we have it here. And you are being asked to calculate what portion of the container, which is volume, will the gas occupy if the temperature is reduced by 1/3. 1/3 is 1/3. So remember, your initial temperature is 60. So to get 1/3 of 60 is simply to divide 60 by 3. Or you put 60 all over 1 times 1/3. So if you 1 will definitely cancel out 1. There's nothing there. So 3 going to 60, you have 20 as your final temperature in degree Celsius. Okay, so we now know that our final temperature is 20 degree. Now, I can decide to solve this question in a different way, but you know how I got this formula, how I'll be deriving this formula in question 1 and 2. So V2 is V1 T2 all over T1. Now, if you use 2 to divide 2, you have 0.66666 to infinity 7 times, then T2 is actually 20 all over 60, which is T1. Note again, V1, 2 over 3, which is the same thing as 0.666 infinity. So we'll just abbreviate to what? 0.667 times T2, which is 20 all over T1, which is 60. Use this to multiply this, you have this. You have 13.33 to infinity, then all over 60. And if you carry out the division, you have 0.22222 to the end. Now, this is the same answer as 2 all over 9. I can decide to solve, I'm using calculator to solve this, but I can decide to solve without using calculator. It's actually easier, but to make it so easy for you, you can use this method. Is still correct. Now, in case you are not allowed to use calculator, just put your 2 over 3 in this place. How do you solve the whole system? Just multiply both sides by, multiply both the numerator and the denominator by 3. You are good to go. You've changed the whole thing, and you can easily solve it without using calculator. Thank you for watching. Please subscribe to support this channel. Thank you.